In this video, let us continue to solve problems based on complex numbers. Alright, here we've got a problem which reads like this. It says if a plus ib divided by c plus id equals x plus iy, prove that a minus ib divided by c minus id equals x minus iy. Alright, so this is one part of the problem, and that's a pretty simple one, which I'll tell you what it is in a moment. And a square plus b square divided by c square plus d square equals x square plus y square. You also have to prove that if a plus ib divided by c plus id equals x plus iy, you not only have to prove that a minus ib divided by c minus id equals x minus iy, but also prove that a square plus b square divided by c square plus d square equals x square plus y square. And one thing is about this particular part of the problem, you cannot go to this particular part of the problem before proving this is equal to this. So even if the question wasn't there like this, you had to come to this step before you have to go to that step. All right. So let's see, how do we prove a minus ib divided by c minus id equals x minus iy. It's a very simple way to prove that. So we have a plus ib divided by c plus id equals x plus iy. All we have to do is we have to prove that a minus ib divided by c minus id equals x minus iy. But everything else is the same. You just have to change the plus to the minus. So you know what you have to do in that case, right? You just have to find the conjugate of each and every complex number here. So the step is going to be like this. Taking conjugate on both sides is what you're going to do now. So it's going to be like this. It's going to be a plus ib divided by c plus id. You need to use a bracket here, and then whole of conjugate equals x plus iy bar. That means conjugate on top of x plus iy as well. So a plus ib becomes a minus ib, and c plus id becomes c minus id, equals x plus iy becomes x minus iy. If you're wondering how, when you take conjugate of a complex number, all that you have to do is change the I to negative I. That's exactly what you have to do. So we proved one part now. Now we'll have to go to this part. So let's say this is equation 1 and this is equation 2. Now what we'll do is, let us multiply equation 1 and equation 2. Alright, so when you multiply, when you multiply 1 and 2, what happens? This is what we get. So left hand side times left hand side, right? I mean, a plus ib divided by c plus id multiplied by a minus ib divided by c minus id equals x plus iy times x minus iy. So multiplying these is very simple because it is of the form a plus b times a minus b, which is a square minus b square. So you're going to get a square minus b square, that is I square b square, divided by c square minus I square d square equals, again it's x plus y times x minus y, sorry, a plus b times a minus b, which is a square minus b square. So it's going to be x square minus I square y square. And you know that the value of I square is negative 1. So it'll be a square minus of minus 1 is going to become plus. So it's going to be plus b square divided by c square. I square is negative 1. So negative of negative is positive. So it'll be c square plus d square equal to same thing here, x square, and I square is going to be a negative 1. So negative 1 times negative 1 is positive 1. And it's just going to be plus y square. And this is exactly what we've got here. So hence we've also proved that a square plus b square divided by c square plus d square equals x square plus y square. So the concept that you've used to solve this particular problem is nothing but the conjugate of complex numbers. So that's one concept which you've applied. Otherwise, it's pretty much basic mathematics is what I'd say. We haven't even used the multiplication here, the complex number multiplication. We use the algebraical multiplication, that is a square minus b square. Alright, so that ends this video. I'll see you in the forthcoming videos with more problems based on complex numbers.